Here are the disasters in the different categories broken down by region. And you see, now I divide them into 4 categories. I talk about the geophysical, again, the earthquakes, the hydrological, which are to do with floods, meteorological, to do with cyclones and storms, and the climatological, which are to do with drought conditions of like that. And in Europe, the main ones are climatological and geophysical. In Africa, they are mostly related to drought. In Asia, we have a lot of deaths from all sources, but particularly the largest is events related to drought. But then we have the earthquakes, hydrological, and then we have the meteorological ones, storms, cyclones, and so on. So these are the kind of breakdown, and these are in thousands, these numbers. So that's in Europe we have had in that period 83,000 people die from climatological related disasters. So what can we say? The droughts are the most common cause of death, followed by earthquakes. Deaths from earthquakes have been the biggest cause of deaths since 1987, more than all other causes put together. Annual deaths due to floods have been rising, while those from storms have been declining over this period. So we are seeing an increase again, and some of these are related to climate change issues, which we may discuss later. The greatest number of deaths is in Asia. So if I look at the numbers here, you can see Asia is the most affected continent. Deaths are preventable, and one of the issues which I'll discuss in a minute is that, for example, in earthquakes, the majority of deaths are caused by collapse of buildings, which cause crushing injuries to the head and the chest or other internal injuries. And although 75% of deaths are due to these factors, deaths per earthquake have been declining because of due to building strengthening and the change in materials that we use. And I'll talk a little bit about how to determine whether this should be done. One of the things which is a little bit of concern is that more deaths occur among women in developing countries as a result of these injuries. So, for example, 70% of the deaths in the Indian Ocean tsunami were women, which would be surprising, because why would that happen? Why should women suffer more? Somehow there's something which we haven't really got a good understanding of. And for injuries, most common causes for injuries, not deaths, are earthquakes and floods, because floods not only cause deaths not only cause injuries immediately, but the subsequent waterborne diseases cause illnesses and so on. Now, just to talk a little bit about how to measure disaster losses, we want to take measures to reduce them. So here are the main losses from disasters estimated as follows. What is the result of a disaster? Well, and some of these figures I'll come back to later, but the main areas of damage are, of course, human capital, human lives, and so on, but also physical capital, natural capital, and so on. And one of these studies shows that earthquakes, the main losses that we suffer are human casualties, followed by buildings. Yeah. From wind-related disasters, these are things which are caused by cyclones and so on. Again, it's human casualties which are the biggest causes, followed by business displacement. In the case of floods, it's mainly buildings and physical capital which is lost. Therefore, clearly the value attached to human casualties will be critical in the evaluation of many of the disasters, although not all of them. And other factors which are important in valuing the damages will be, and the reason will become clear, is the discount rate you apply when you decide upon the expected damages, because you cannot, of course you can calculate the damages ex post after the event, but what's more interesting in deciding on introducing measures is to know what are the damages ex ante. What would be the expected damages from a set of events. And for this, you have to look at each year the probability of the event, and therefore you have to apply some discount rate to the future. And then whether or not you include a risk aversion component, whether in fact in valuing the expected damages, you value the risk in addition to just the expected damage. And the reason I'll give you here is that when we were looking at some of this work when I was at the World Bank, there had been some big earthquakes in Turkey. And in Turkey, we carried out a kind of, some colleagues carried out a benefit cost analysis for trying to strengthen buildings in school buildings. And school buildings program, the main thing which determined whether to do it or not was what value you put on a life. Because, of course, you don't know how many people will die, but you know that over a period of time, if you have stronger buildings and they collapse, you will have fewer deaths. And we needed a value of about $400,000 per life to get this test passed. Now, if that same test was applied in the EU, in the work we do to determine issues like air quality laws, measures to determine road safety and so on, we take a value of around 1 million euros, which is about $1.4 million now. Is it? 1.3 something. So, so if we were to do this test in Europe, it would pass the test and we would install these measures. But in fact, some people think even 1 million is too low. We should have a value of life for European value should be around 3 to 4 million. But of course, in a country like Turkey, we needed a value like that to get the test passed. And in fact, here's the only thing I will give you today, which is mathematical. But what you need to calculate is something like this to do the benefit cost analysis of these different disasters. You need to have the probability density function for different events. For an earthquake of severity A in year T, you need to know the damages that will be associated with that, and you need to multiply that by the damage, the value attached to that damage, and then you've got to discount it from over a period of time. Now you know that these damages will occur in a number of different locations, so you've got to sum over I. And so this is the kind of test the kind of assessment you have to do. And in doing this assessment, you have to, what's quite important is what rate, of course, you apply here, discount rate. But what's also very important is what damage you put in here. And that damage value and a very big part of that damage value is this value of human life or human consequence. And that's why it's important to take the right value.